weight also increases. So here R is maximum at the equator, G is minimum. And what about weight? When G is minimum, weight is also minimum. W is minimum, right? So here at the equator, weight is minimum. So the quantities R is responsible for all these things. So R is maximum at the equator. From the equation, whenever R is maximum, G is minimum. Whenever G is minimum, weight is also minimum. These are the two equations responsible for all these conditions. So R is maximum at the equator, therefore G is minimum at the equator. Whenever G is minimum at the equator, G and W are directly proportional. Whenever G is minimum, weight is also minimum. So weight is minimum at the equator. Coming to the poles, what happens? Coming to the poles, it R is minimum at the poles. Minimum at the poles. So whenever R is minimum, what happens to G? G is maximum. Small letter G is maximum. When G is maximum, what happens to weight? Weight is also maximum. So this is the condition. That's why we say that weight is varying. So here R is minimum. At the poles, R is minimum. Whenever R is minimum, G is maximum. Whenever G is maximum, weight is also maximum. Right? This is the thing. So the weight is a varying quantity such that weight is maximum at the poles and minimum at the equator. Why? Because radius of the earth is maximum at the equator and minimum at the poles. Radius of the earth is maximum at the equator and minimum at the poles. Whenever the radius is maximum, acceleration due to gravity is minimum. Whenever the acceleration due to gravity is minimum, weight is minimum. When radius is minimum, acceleration due to gravity is maximum. Whenever acceleration due to gravity is maximum, weight is maximum. So from this, it is clear that weight is a varying quantity such that weight is minimum at the equator and maximum at the poles. I think it is clarified. Okay, moving to the last topic. Units. Already we know the units of mass and weight. Already written in the table. The unit of mass and weight is, mass is the unit of mass as a unit. The unit of mass is kilogram and the unit of weight is Newton. Newton, or otherwise another unit is kilogram meter per second square. Why these units come kilogram meter per second square? Why these units come? Because weight is equal to mg. The unit of m is mass is kilogram. The unit of acceleration due to gravity. Acceleration due to gravity is simply acceleration, that is meter per second square. So these are the things in the third section: motion under gravity, mass and weight, and their units. These are the things in the third section. So we completed 3 sections. There will be another section is remaining. In that section, we discuss about the weight of the particle in the moon as compared to the weight of the particle in the earth. That is the last topic of the chapter, and that is we discuss in 4th section. Okay. Moving to the last topic of the chapter, gravitation. Right now on the board, this is the topic: weight of an object in moon. How to calculate the weight of an object in moon? Here we are not calculating the weight of an object in moon. Here we are comparing the weight of an object in earth to the weight of an object in moon. We are taking the ratio of weight of an object in moon to the weight of an object in earth. So to taking the ratio, we have to compare these two weights, that is weight of an object in moon and weight of an object in earth. How to compare? If a quantity A and B is given to you, and just say that how to compare these two quantities A and B. To compare these two quantities, just divided A by B or B by A. Like here, we have to compare the weight of an object in moon and the weight of an object in earth. So how will you calculate the weight of an object in earth? How will you calculate the weight of an object in earth? As we all know that According to universal law of gravitation, the force is given by the equation F is equal to G into mass of the first object into mass of the second object divided by the square of the distance between them. Here, in this case, as we know that weight is the force exerted by air. So, assuming that a body of mass m or a particle of mass m or an object of mass small letter m is on the surface of the earth. Okay, so we can write the force of interaction or the force of attraction. The force is also called weight. Force is also called weight. Weight is equal to G, capital letter M is the mass of the earth, small letter m is the mass of the object by distance square. What is the distance? Distance from the center to the surface is considered as the radius of the earth. So distance square is r square. So weight of the object in earth is taken as WE. So WE is equal to WE is equal to WE is equal to G is, we know that 6.67 into 10 raised to 11 Newton meter square per kilogram square. 6.67 into 10 raised to 11 minus 11, not 10 raised to 11, it is 10 raised to minus 11. That is weight of an object in earth W is equal to 6.67 into 10 raised to minus 11 into, what is the mass of the earth? Mass of the earth is given as 6 into 10 raised to 24. 6 into 10 raised to 24. What is the mass of the object? It is not given. Mass of the object in earth and the mass of the object in moon is always same. Therefore, we can given the letter simply small letter m. By what is the distance square? R square. R square is 6 point. Radius of the earth is 6.4 into 10 raised to 6 the whole square. So that's all about the weight of an object in earth is this one. We have to calculate this value by avoiding m because m is same as small letter m. That means a mass of the object is same as in both the case, in earth and in the moon. Okay. Then we have to compare the value of the weight of the object in moon. Okay. Right. So how will you calculate the weight of the object in moon? Weight of the object in moon is also have the same equation. G, capital letter M, mass of the moon, mass of the object by the radius of the moon, that is radius square. So weight of the object in moon W m is equal to 6.67 into 10 raised to minus 11 into mass of the moon. What is the mass of the moon? 7.4 into 10 raised to 22 into mass of the object is same. So small letter m by, what is the distance? Distance is 1.7. We have to take the radius of the moon 1.7 into 10 raised to 6 the whole square. So how will you compare these two weights? Weight of the moon divided by weight of the earth is equal to, weight of the moon is 6.67 into 10 raised to minus 11 into 7.4 into 10 raised to 22 into mass of the object divided by 1.6 into 10 raised to 6 the whole square. This is the weight of the moon, weight of the object in the moon. Then we can write the divided whole divided by weight of the object in earth. By whole dividing, we have to multiply these two equations by taking the reciprocal, that is into, here the reciprocal is 6.4 into 10 raised to 6 the whole square